Making a class system is hard, but the theory behind it is actually very easy. So today you're going to leave this video understanding exactly how characters and stats work, and then I'll trust you to figure out the rest. When you pick a character in a game, it feels like you're choosing something meaningful, a class, a playstyle, or a role. But under the hood, it's way simpler than that. So let's start with stats. In almost every Souls-like, your character isn't really a class at all. It's just a collection of numbers, and the class you pick determines those starting numbers. Strength, dexterity, vitality, endurance, all of them have a corresponding number, and those numbers don't actually do anything on their own. Instead, the game uses them in formulas and checks to make them matter. A really easy way to visualize this is Baldur's Gate 3, because it follows the same rules as Dungeons & Dragons. For every 2 points that you put into a stat, you get 1 more damage. Your baseline is 10, so at 10 you have +0 and -0 to your damage. If you have 18 strength, your weapon does 4 more damage. At 20 it does 5 more damage. Very simple. Souls games do the exact same thing, just with way more complicated math. Here's the formula Elden Ring uses, but I'm not going to explain it. The important takeaway is this: stats are just numbers, and the game uses them to calculate other things. Sometimes that is super simple. Like in Fallout New Vegas, if you have enough strength, you can knock someone out using this option. That's literally just an if statement. Other times it's more complicated, like weapon scaling. You can't know what values feel good right away, so you build a formula and then tweak how much those stats matter until the game feels right. But no matter how complex it looks, it all comes back to the same thing. Stats are just numbers, and you use those numbers to calculate other stuff in your game. At the most basic level, I could give a character a strength stat, and then check if it's high enough to move a cube. That's it. This is now a working stat. Now for the more complicated part, character classes. And for this to make sense, you need to understand one core idea in programming: the ability to create something called a class. Yeah, it uses the exact same word. Don't worry, not confusing at all. In programming, a class is basically just a blueprint or a template. It defines what something has or is allowed to have. So for a character, your character class might be health, stamina, strength, inventory, abilities. But you don't define those numbers here, you just say that this is what the class should have. Again, it's a structure, or a template. Then when it comes time to actually create a character, you fill in the numbers. So instead of strength just being a variable, you now set strength equals 12, health equals 100, stamina equals 50. Now throughout your game, wherever you check these numbers, the game will actually have something to work with. So when a game gives you a class, like a warrior or mage, it's just taking the same base character and filling in the numbers differently. Maybe giving it different abilities, maybe tweaking how these numbers are used, but under the hood, it's still the same structure. But now you might be saying, okay, if it's all using the same base structure, how come they can play so differently? Well, there's one more piece to this that makes these classes feel different. Most games don't build one giant system for a character. They build smaller systems and then combine them. So your base character probably has things like walking, jumping, rolling, and attacking. These aren't tied to any specific class. They're just part of being a character, and this means that you don't have to recode these same things constantly. Then when you create a new class, a game class, not a programming one, you don't rebuild everything, you tweak what's already there. Maybe this character moves faster, or has a heavier roll. Maybe one overrides attacks with a completely different animation. But they're still using the same core system. The difference is just how those systems are configured. So here's a really quick example of how this might work. I've got a basic character here with simple movement and controls, but when I click, it runs something called use item. Now the important part is, the character doesn't actually know what that means. The item has the code that handles what it does. So if I use the flashlight, it toggles on and off. If I use the gun, it shoots. Same input, completely different behavior, and not at all tied to my character other than the ability to use the item. This is a really good example of how you can program your systems to be more easy to expand. Because now I could make any item, and if I want characters to use that item differently, that can be part of their character data. But if I don't, well, then the weapon knows what to do. In a game like Destiny, your base character has things that they can do, and then your class determines what abilities you're allowed to use. It's just different pieces being combined in different ways. So whether you're picking a class or building your own character from scratch, you're still interacting with the exact same underlying system. Now, if you look this up online, you're going to start hearing words like inheritance, polymorphism, and abstraction. And yes, these are real concepts. But for understanding how this stuff actually works, I'd say this is a really good spot to start. At the end of the day, any game that has stats are just using those numbers throughout their system in various ways. The difference is only in how the numbers are used. And by understanding this, you can look at almost any game and break down exactly what's going on under the hood. As a final point though, what I'm describing is just the most efficient way to not have to keep recoding stuff. There are certainly games where every single character has all of their own custom code. That's just not typically how it's done. The dev just did way more work to make it all work. Alright. Anyway, as always, thank you for watching. Please like the video if you enjoyed, and until next time, see ya.